when we discuss functions, I think the main thing we can think about is that a function is sort of like a machine. There's always some sort of input value, and in most cases when we're talking about function, that's going to be our x variable, and it's going to give you some sort of output. Now up to this point we've always called that y. But moving forward, we're going to see that written in function notation where it says f of x, so the function in terms of x, or g of x, which would be just another way to represent a function called g. H of x, again, another way to represent a function, just calling it h. But what we should think of is our x values are our inputs, and then whatever we get from that input would be our output, which is either our y value or our f of x value, or whatever value we're looking for. We're going to see an example here. And the input is time, the output is pages. So the function, you read 50 pages per hour. So if you input 5 hours, you should output 250 pages. So the basic definition for a function in a nutshell, you have some sort of input which gives you some sort of output. And you can see the example of the last function I was talking about, 50 pages an hour would be our function. If I put that in function notation, I could say that my function in terms of x, which is time in hours, is equal to 50 times the amount of time that has gone by. So if I plug in 1 hour, I get 50 pages read. If I plug in 2 hours, 50 times 2 is 100. 3 hours, 50 times 3 is 150, and so on and so forth. And you can see that function now has been created. The functional relationship, then, what we're looking at, anytime we have a functional relationship, we can put any input, but there only can be one unique output. We can't have multiple outputs for the same input. We can't read for 3 hours and read 150 and 200 pages. That just doesn't make sense. That's not a function. When we're looking at functions, we want to test equations to see if they are functions, or test relationships to see if they're functions. There's two things we can do. If we have a set of ordered pairs, we can look at those ordered pairs and really just make sure that there's no repeated inputs, which would mean there's no repeated x values. In our first relation here, we can see I have 3 different sets or 3 different ordered pairs. Now, point 1 and point 3 both have a x value or an input value of 0. Since they have different output values, this is not a function. Because remember, each input value can only have one output value. In this relation, 0 has an output of 4 and an output of 0, which means it is not a function. Now, on the other hand, if we look at the second set of ordered pair over here, where I have 4 points, I got 1, 2, 3, and 4, I can see that each of my x values is going to be unique, meaning that they're not repeated. So I know that as long as they're not repeated, every input has one output, which means I do have a function. So looking at our ordered pairs, it's a little bit more difficult to interpret to see if it's a function or not, but what we're looking for is that unique input and no repeats in the output. Then we go to a graph and things get a lot simpler because we can use what's called the vertical line test. If we have a function, whether it's points or a line, if we draw a bunch of vertical lines, and if we look and we say at any point does this vertical line hit 2 points, I can see here it does. If it fails that vertical line test, that means it is not a function. So when we look at our graph, if we just draw our vertical lines, it's pretty easy to see whether it's a function or not. And if we look here at the table, we have just a bunch of different ways that we can represent a function. We can have a list, which is where we just have a bunch of ordered pairs written inside of a list. We can have a table, which we've seen before. We have our x column, our y column, and those pairs correspond to each other. Mapping as well, very similar to the table, except we're drawing a line from the input to the output. So nothing new there. Obviously, we're always going to be able to have a verbal description. We're always going to be able to use words to describe some sort of function. And that'll be something that we can always do. The equation and the function we can see are awfully familiar, and they look very similar. The only difference here would be we're using y here, we're using f of x here. Otherwise, it's still the same exact representation. We're talking about the same relation. And then the last thing which we've been looking at would be our graphs. We know we can always graph ordered pairs on a coordinate plane because we have an x value and a y value. Or in this case, we're going to start think of it as an input value and an output value. And the last thing we will look at, which we talked a little about, is our function notation. Our function notation, all we're doing is we are representing our y value as a function. So in terms of f of x or g of x or whatever variables it is that we are using. That means that we are going to input x and the output will be 2x plus 5. So if we inputted 3, we'd plug in 3 for x, we'd get 2 times 3 is 6, plus 5 is 11. The input was 3, the output was 11. And we could see then, again, it talks down here very similar to saying we've got y equals 2x plus 5. We've got f of x plus 2x equals 5. Either way, I can write my input as my x, my output as my 11. And then we can graph that.